Hello everyone. So in this session we will continue with the Python session number second. Okay. So previously we had discussed about Python fundamentals, Python course content, Python variables, data types, etc. Okay, Python history, Python 2 versus Python 3 and Python features. Okay, so if you want to check out that previous video, so you can visit the YouTube channel. Okay, so here you can search for the channel name, that is G2 Jaswal. So from here you can watch the session number 1, that is Python day 1. Okay. So you can watch the session, the player basics. In this section we will discuss about typecasting, conditionals and loops and functions. Okay. So first we have typecasting. Okay, before moving forward, let's take a recap. So what is variables? Variables are the containers which stores your values. Okay, for example, a equal 10. So 10 is a value and a is a variable, and we are assigning 10 value to variable a. So this is a variable. In rules of naming a variable, like we have naming conventions, that is known as rules of naming a variable, because we cannot name anything to a variable. Okay, for example, first rule is spaces are not allowed, but you can use underscore. Numbers are not allowed at first, but you can use in middle and at last. Whereas special characters are not allowed, reserved words are not allowed. So these are the naming conventions of variables. Okay, now we have data types. So data types are the kind of values we are storing inside inside a variable. So data types are the kind or type of value we are storing inside the variable. Okay, that is known as data types. So these are the kinds of value we are storing inside any variable. For example, a equal 10. So we are storing 10 value to variable a, and 10 is which type of value 10 is. So that is known as data type. Okay, basically 10 is an integer value. Now we have types of data types. So first we have strings, numbers. Inside numbers we have integers, float, complex. Okay, and we have Boolean values. Inside Boolean values, we have two values, that is true and false. Then we have list, we have tuples, dictionaries, set, and frozen set. And these are the data types we have. Okay, so strings are like the group of characters inside double quotations, single quotations, and triple quotations. Numbers are like we have three types of data types inside numbers. We have integers, which is like a simple numbers, for example, 15, 63, etc. These are simple numbers without decimals. Float we have, which is known as floating point numbers, in which we have decimal numbers. Okay, so these are known as float numbers. Complex number, it is like a combination of real and imaginary number, that is 2G. Okay, so 1 and 2 here is a real number and J is an imaginary number. Okay, so here we have Boolean values, that is true and false. We have only two values inside Boolean, true and false. And let me write the example of a string, that is hello world. Okay, whatever you were writing inside double quotations, single quotations, okay, these are known as quotations, or triple quotations are known as strings. Now we have list, so anything inside square brackets are known as strings. Tuple we have inside parentheses, dictionary, curly braces, set inside curly braces. Dictionaries are known as key value pairs. And set, frozen set, it is like a constructor here. Okay. So and then we had discussed about the mutable and immutable data types. Mutable is like we can change the type of elements, we can change the values of the elements, we can add values, we can remove values. Immutable data types are like the data types in which we cannot change the values, we cannot remove or we cannot add values inside any data type. Okay, so we can take an example of list. So list can contain numerous elements like apple or like strings, numbers, or any boolean values, and even list inside list. Same as tuples. Tuples can contain any type of data type, like they can contain strings, numbers, float numbers, complex numbers, boolean values, list inside tuples or dictionaries inside tuples, etc. Okay. Now we have dictionaries. They are like key value pairs in which we have, let's say A. So A is a key here, 1 is a value, comma, B is a key here and 2 is a value, comma, and C is a key here and 3 is a value. So A is a key which is separated by a colon and we have a value. So this is one key value pair, and this is second key value pair, and this is third key value pair. Okay, these are known as dictionaries. Now we have set. So set are also inside curly braces. So here we have multiple elements inside set. Okay, and the list are mutable in nature. Tuples are immutable in nature. Dictionaries are mutable in nature. Set are both mutable and mutable both. So we can write mutable and immutable both. And frozen set, they are like fully immutable. So in the mutable, we cannot add value. In the mutable, we can add values. We can remove any values. Okay, values are like apple is a value, or we can say elements. We can change the values of the elements, like we can change apple with any other value, etc. Immutable is like we cannot change values, we cannot remove values, we cannot add any value. Dictionaries are like immutable, we can change, we can add, we can remove. Set is like both immutable and immutable because set itself is mutable, means we can add values, we can remove values. And but elements of set like apple, oranges, these are elements of the set, they are immutable, means we cannot change the values of these elements. Okay, and then we have frozen set. It is like to create set fully immutable, we use frozen set. Okay. Now we have typecasting. So typecasting is the process of converting your one data type to another. So here we can write it is a process of converting one data type to another. That is known as typecasting. Okay, means we are changing one data type to another, that is known as typecasting. For example, we can change string into integers, we can change integers into float, float into complex, or we can change list into tuples, tuples into list, etc. Or set into list. So these are known as typecasting. So let's take an example here. So we'll create a file here. Okay, data. dot py, the extension of file. We can open this inside VS. Okay, so now we can. So let's create a list here, string here. Let's say we have this string. Just name this A. Okay, now 10 is a number, but in this case, in the Python case, we are using quotations here. So now this is a string. This is not a number anymore. This is a string. Okay. So now we can convert your string into numbers. So if you want to check, we can check the type of data type. Your variable number A is storing. That is string. We can run this. Okay, so we have class string. Even we can check it out. Now we can convert it. So we can create a variable. Now we want to convert variable number A to integer. So we put int for the integer and which variable you want to change. That is B. Sorry, A. So we want to print. We will check the type of value the B variable is now storing. That is integers. Okay, because in variable number A we have 10 value. 10 is a string here, and we are checking the type of value we are storing inside A. That is string. And B here, B is an integer. So here we are converting string into integer. And suppose if we have any like alphabets here, let's say Python. Okay, and if we try to change it, so this will throw an error because alphabets are like they are invalid. Okay, we cannot convert them into numbers. Okay, so we have this A and we have this B. If we have like numbers only, then only we can convert. Otherwise, if we have strings, we cannot convert. Okay, so this is how we can convert your strings into integers, or we can convert into float. So here you can put float here. Now, if we check the data type, so it is string. Previously, it was a string. Now it is a float number. Okay, so the value of the type of value the variable B is storing is float. Okay, and A is storing a string. So we are converting your string into float now. Okay, so now we can convert your integers into float or integers into strings. Suppose we have number 1, that is num1 equal 10. So 10 is a number here. Now we can convert int into string. So we can use str_1, that is string underscore 1, and we will convert str and which number we want to convert num1. If we check the type of variable, type of value your variable string underscore 1 is storing is so here number 1 is 10. So we're storing a 10 number to a variable number 1. Here now we are converting integer into strings. Okay. So string number 1 is a variable and we are converting here your integer that is 10 into string. Okay. So if we check the data type here, print type of value number 1 is storing. So here it is. First it was integer and then it was, we can check the type here. Now it was a string. Okay. Same as we can do with the help of float. So here we can put float. And you can run this. Previously it was integer. Now we are converted into float. So it is now float value. And we can run this as well. Print. We can print the value here and print string underscore. Okay, so 10 is an integer and 10.0 is a float number. So this is how we can convert your integers into float, float into integers, or string into integers and float. Okay. Now we will convert your list into tuples, tuples into list, or set into list, or etc. So list underscore one. So we have a list of let's say of some elements, and we have some values here. We have some boolean values here. We have some complex number value here, etc. Okay. Now we can print the type of value your list underscore one is storing. Okay, that is list. And if we print list underscore one, that is this list. Okay, so apple is a string here, orange is a string, 1, 2, 3, 4 is a numbers, that is integers, 2 is a boolean value, and this one is a complex number. Okay, now we will convert your list into tuples. So we can put a comment here converting list into tuple. That is tuple underscore one. Now we will call a tuple constructor here, and we will put which value we want to convert. That is list underscore one. Right. So here we can put list underscore one. Now we can check the type of value the tuple underscore one is storing after converting. Okay, and we can print the value tuple underscore one. If we run this, here you can check it out. We have list and we have this list because it is inside square brackets. And we have converted list into tuples. Now this is a class tuple, like type tuple, and we have this tuple here. Okay, that is we have elements, we have numbers, we have boolean values, and these are inside parentheses. So now we will convert the set into frozen set. Okay, set underscore one, and we will create a set here that is inside curly braces. Here we can put some few elements. Let's put some numbers here. Now, print the type of value set underscore one is storing, and then we can print set underscore one itself. Okay. So here that is set. Now we can convert your set into frozen set. That is, we can call, let's say we have a variable frozen underscore one. We will call a frozen set constructor here, frozen set underscore one. If we check the type of value, the set and frozen set underscore one is storing, that is frozen underscore one, and we can print the value of frozen underscore one. Okay, here we are checking the type, and here we are printing the values. So there's a difference. Okay, so here we have a set, and here we have a frozen set. The same set is converted into frozen set. Okay. And same like you can convert your set into tuples into list or tuples into set of etc. Okay. So this is how we can perform typecasting using data types. Now we have functions. So basically we have various functions in Python. So first we will look at how user defined functions. Okay, how we can define our own functions. Okay, so the syntax of functions are def. Your keyword here means your function name. So function underscore name, parenthesis, column, and your set of statement, that is statement. Okay, that is the syntax of function. And here we can print function underscore call, parenthesis. Okay, for example, if you want to print something, let's say if we want to print hello world, So how we can convert, how we can put that print statement inside function. So we can put def and your function name. Let's say fun. Parenthesis, colon, space, enter, and indentation. Now set of statement print. Hello. Now we can call the function. Okay, so this is how we can create functions. So let's see. Def fun, name of my function here, parent colon, print. So the motto of this function is to print something. That is hello world. Now we can call the function here. We can run this here. So here we have hello world as answer. So functions. So there's some point to remember for the functions. So points to remember. So why we use function or what are functions? Okay, so we use functions for we can say for the systematic coding or for reusing the code again and again. So we can use for reusing the code again and again. Secondly, functions are useless until you call them. Okay, so it is very important to call the function. Otherwise, functions are useless. For example, let's remove this. So we have this function. So this is the function structure here. Okay, this is our def. Def is a keyword which means define. Fun is a name of my function, parenthesis and colon. This is known as indentation. Okay, a little space is known as indentation here. And print and indentation is important. When you remove this, Python will throw an error. So indentation is important and print is a statement, hello world. So the motive of this function is to print hello world, right? Okay, so now let me run this. Okay, so we don't have any output. Why? Because this is a function structure and functions are useless until you call them. So now we have to call function. And how to call? Name of a function in parenthesis. Fun parenthesis. Now when we run this, we have a output here. Hello world. Okay. So this is how we can create functions. Now let's create another one. Def fun underscore fun one. Okay. Here we can put print this is another function. And we can call this fun one parenthesis. And when you run this, so we have that another function. And this is known as function call. And this is known as defining the function. And this is known as set of statement inside function. Okay. So this is how we can create functions. And functions are useless until you call them. So it is very important to call your function after creating it. Okay. So you can call them anytime. Suppose this is fun1 and this is here you are calling. So first we have created fun1, fun function. And secondly, so fun1. Okay, and now the sequence of calling is I'm calling function1 first and then fun. So the sequence is like first this function will be printed and then this function will be printed. Okay, for example, if you run this, so this is another function and hello world. So first this one is printed and second this one is printed. Okay, so let's understand the flow of code here. So here the code is flowing from top to bottom. Okay, so this is useless code. This is useless code because this is just a function. Okay, we have to call them to use it. Now here I'm calling fun1 first. Fun1. So the Python interpreter will check out this fun1. Fun1 is this one. So this will print. This is another function. Okay. Second, I'm calling the fun. That is before fun1. Okay. And here hello world here. Okay, so this is how we can create functions, we can call functions. These functions are like without arguments and keywords or parameters. So we will create functions without with parameters and arguments. Now, what is parameters and arguments here? So let me show you. So we can put a comment here: functions with arguments and parameters. Okay. Def fun underscore one. Parenthesis. Now print. And here we are calling a function. Okay. Right. So this is my function syntax. Now here we can put any number of arguments. Let's say a comma b. So a and b are arguments. A and b here are arguments here. And print, let's say we are printing the value of a and b. So the value we can put in the strings a and b. One second. Yeah, so the value of a and b are, here we can put call a and b. Okay, sorry, comma here as well, a and b. Now we can put, so these are values, mean these are parameters. Sorry, these are parameters, not arguments. Okay, and now we have to provide values to these parameters. So we can put here 5, 6. So 5 and 6 are arguments here. 5 and 6 are arguments of a and b. And when we run this, we have a value. The value of a and b is 5, 6, which is a value is 5 and b value is 6. So this is again put arguments and parameters. So these a and b are parameters because we are using it when defining the functions. And 5 and 6 are the arguments which is we are using it while calling the function. Okay, so there's a difference. A and b are parameters and 5 and 6 are arguments here. Okay, so let's perform arithmetic operations using functions. So here we can put, let's remove this. Yeah, we can put def add a comma b. So we want to add a and b together. So we will use return here. Okay, so instead of using print, we will use return here because we want to return the values of a and b by adding it. Okay, so here we can put a plus b. Now we can call function add a and b and we can use the values. Let's say 5, 6. Okay, now here we are using the return. So here we have to use print here. Print add a and b here. Okay, when you run this, we have output 5 plus 6, 11. Okay, so whenever we are using return here, we have to use print here. Okay, here. And whenever we are using print here, we just need to call the function. Okay, like for example, here we are using just print function. So whenever we are using the print inside functions, we have to call the function here. No need of print using print here. Okay, but whenever we are using return inside function, return keyword inside function, so we have to use print while calling the function. So there's a difference. Okay, and if you remove this print statement, see, and when you run this, so this will show you no output because you are returning the value, but after returning the value, we have to print it. So we need to print the value. So print add fun and this one. Call the function and return the value and print the value. Okay. So here we are returning and we are printing the values. Okay. So now let's create a complex function. Okay, def fun underscore one. So let's take four parameters here: A, B, C, and D. Okay, so A, B, C, D are parameters. So we can use as many parameters as we want. Okay, now we can use return and we can add values A plus B plus C plus D. Okay, and then we can print one underscore one and we can put values like A, B, C, D values. So 1, 2, 3, 4, any values you can put. Okay, and make sure here. So here's a note: parameters equal arguments. Okay, like here we are giving four parameters. So we have to put four arguments here. Okay, so parameters will equal to the arguments. And suppose there are like four parameters, and here we have given only three parameters. So this will throw an error. Okay, so Python interpreter will throw an error because here we have four parameters and we are giving three arguments here. So here we can put four. So four parameters, four arguments. No way. Okay. So here we have answer of 1, 2, 3, 4. Okay, like by adding this, we have the answer. So this is how we can use parameters inside functions, parameters and arguments. Okay, now there's a default arguments also. Like default argument. So here def is a keyword, function name. Name is a parameter here. Now here we are giving a parameter a value that is John. Okay. And we are returning the name. Means we are printing the name. And we are printing and we are calling the function. So here we have provided a default argument here that is John here. Okay, to a parameter inside function defining. So whenever we are giving a default argument, so it is not necessary to put arguments here. Okay, so this will not throw an error when you run this. So we have the answer John. But if we are giving any argument here, let's say Lily. Okay, now when you run this, so this argument Lily will override this John argument. Okay, for example, if you run this, we have a Lily. So the default argument is John here, but whenever we are given any additional argument, so this Lily will override this John value. Okay, so John here is a default argument. Okay, and Lily here is a argument here. Okay, this is the argument that is provided by when calling the function, and this is the argument when we are using when we are like defining the function. Okay, and we can call the function as many times as we want. Like fun, we can call it again without arguments. So here we have Lily and then we have John, the default value. And we can call this again. That is the benefit of using the functions. We can call it as many types as we want. Okay, so we can write on here. Okay, so now Python will override this John value. This is how we use the functions. Okay, this is how we can create the functions. Now we have operators here. So first we have arithmetic operators. So inside arithmetic operators, we have values like add. So here we have plus, subtraction, multiplication, division, modulus, and exponential. Okay, so we have arithmetic operators. Now we can apply this. So what is modulus and what is exponential that we will discuss. So here we will create num1 as a variable. Let's say value is 5. Num2 Okay, so this is plus, subtraction, multiplication. This is float division. Okay, float division means this will give you output in decimal format. Okay, so it is in decimal format. And we have modulus, exponential, and division. So this division, so we have two divisions. First one is single slash, second one is double slash. So this double slash is, that is integer division. Means we can say that this will give you output only the main part, not a decimal part. Okay, this is known as modulus. Modulus will return the remainder part. Okay, so it will return the remainder part of the division. And then we have exponential. It is like power of. Okay, so here we can put this. So first 5 plus 2, 5 minus 2, 5 multiplied by 2. Okay, now 5 divided by 2. So here we have this as like for the answer is in decimal format. Okay, and the modulus is like it will return the like remainder part. So when we divide 5 modulus 2, so answer is 2 into 2 4. So remainder is 1. So that is remainder part. And we have exponential, that is power of. So exponential is like we have 5 exponential second. That means 2. So this is like 5 into 5, that is 25. Or we can take any value in exponential. Let's say 3 exponential, or we can put 2 exponential 5. So we have answer is 2 times 5, that is 2 into 2 into 2. Okay, so that is 2 times 5. And then we have the single double slash, that is only a integer division. So this will only give you the main part, that is real number, that is 2. This will eat up the decimal part. Okay, that is exponential. Sorry, that division. We have double slash, we have single slash. Single slash will return decimal format. The answer is in decimal format. And double slash will return answer in integer format. Okay. So these are arithmetic operators. Now we have membership operators. So inside membership operators, we have in, we have not in. Okay. Means here we are checking a particular element is a member of that particular data type or not. For example, we have a list underscore one. Okay, and we have a list of elements. Apple, we have oranges. We have some numbers. Okay, up to 9, etc. So here we have some list of elements. Okay, we have strings, we have integers. Now here we are checking print. Let's say 8 in list underscore 1. Okay, basically we're checking whether 8 is an integer. 8 is inside list underscore 1 or not. Means 8 is a member of list or not. So here 8 is a member. So this will return true. Okay, so we have true. Now if we check that print 18 in list underscore 1. So 18 is not part of my list. That is, my list is like have apple, oranges, and 1 to 9 numbers. And here we're checking for 18. So 18 is not a member of my list. So it will return false. So the answer is always in true and false. So we have false here. Okay. Now we will check for any string. Let's say apple. So here we're checking apple in list underscore one or not. Okay. So answer is true because apple is in list. Now what if we put apples? This will return false because here we are checking for apples. But my list contains apple. So there is a difference. So it will check character by character. Okay. Like A is matching, PP is matching L and E. But this additionally S here. So this will not match this string as this is string. Okay. That is why we have this answer. Apples is not in list underscore one because we have apple, not apples. Okay, so there's a difference. So that is membership operator. And in and we have not in. So not in is like opposite of in. For example, we have not in here. Not in, not in. Okay. So it will reverse your answer. That is true, false, false, true. For example, now here we are like checking for the condition whether 8 in not in list underscore 1. That is here we are checking, we are asking to a Python interpreter that 8 is not in list but 8 is there, right? So this will written false here. So here we can put false. Same as we are checking 18 not in list underscore 1. Yeah, this condition is true because 18 is not a part of list. That is true. Same as we are checking for the apples. So the apples is not there, but apple is there. There's a difference. And we are checking for the apples. So apples is not inside my list. So this will return true here. So it is like a opposite of in. Not in is opposite of in. So false, true, true. So this is membership operator. So here we can check. We can take list here, tuple here, dictionary here, set here. We can check elements of any data type here. Okay, even we can check for the strings. Let's say name, or we can say str underscore one, string and underscore one. And we have a string, let's say Python, only Python. Okay, and here we are checking print that whether y in str underscore one. Okay, so this is how we can check for the strings. So we can use it as well. Now, so this is membership operators. Now we have identity operators. So identity operators are like is and is not. It is like we are checking, we are just matching or we are comparing the values. For example, we have num1, we have 10 here, and num2, we have 20 here. Okay, so num1 and num2. Now here we are checking print num1 is num2. So here we are checking whether num1 is equal to num2 or not. Basically, num1 is 10 and num2 is 20. So that is false. So this will return false because here we are checking for the values. So here we have answered false. Now what if we put is not? That is we are checking it is like reverse the condition. So now answer is true here because here we are checking that num1 is not equal to num2 and this condition is true because num1 is 10 and num2 is 20 and this is not equal. That is false here. Okay. True here, sorry. Okay. Now here you can check for the characters. For example, let's say Python. Here we're checking for Python in Python. Now this will return false because Python num1 and num2 are equal and we are checking whether num1 and num2 are not equal. So this will return false here because the condition is false here because Python num1 and num2 are equal. So condition is false. And what if we put is here? So the now condition is true here because number and num2 both are equal. Okay. So this identity operators here we have is and is not in this identity operators. Now next we have comparison operators. Comparison is like comparing the values. Okay, for example, we have in the comparison operators we have these signs. We have equal, we have not equal, we have greater than equal to. Okay, so we have these values inside comparison operators: greater than, less than, equal, not equal, greater than, equal to, or less than, equal to. So we have these values. Now here we can check it out. Let's say we have num1 variable and here we have num2. Value of num1 is 10. Value of num2 is 5. Now here we are checking for the condition num1 is greater than num2 or not. So here we are checking whether num1 is bigger than num2. So answer is true here because num1 is greater than num2. And then this answer true. And what if num2 is 50 and num1 is 10? So now answer is false. Okay, same as we can check for the less than. Num1 is less than num2. Yes, because num1 is 10 and num2 is 50. So answer is true here. And if we put num2 5, so now answer is false because num1 is not less than num2. And here we check for the number. Okay. And we can check for the equal sign as well. Okay, where the num1 and num2 are equal or not. It is false because num1 is 10 and num2 is 5. Here we can put 10 here. So num1 and num2 are both equal. True. And here we have not equal sign, that is this one. Okay. The answer is false here because num1 and num2 are equal and we are checking for not equal. So answer is false. And if we put 1 here, 10 or 1 are not equal. And this condition is now true because here we are checking for num1 and num2 are not equal. Okay. So here we can run this. Answer is true. Or we can put greater than equal to. For this, for example, we have this. Now here we're checking for greater than equal. Okay, this means num1 is 10 and num2 is 1. So this condition is false because num1 is greater than num2. Sorry, this condition is true here. Okay. Now what if num1 is 0? This condition is now false because num1 is less than num2. Or what if num1 is 1 here and num2 is 1 here? So here we are checking for greater than and we are checking for the equal sign both. Okay, for the equal and for the greater than. So here we have answer is 2 here because num1 and num2 are equal. Now, same as we can try with less than. So for the less than, we can put here less than. Now, here we again checking for less than and equal to. So num1 and num2 are equal. So answer is true here. Okay, answer is true. Now, here we're checking, let's say num1 is 10 and num2 is 1. So this condition is now false because num1 is greater than num2, not less than. And what if num1 is 0 here? Now this condition is true. Okay. So this is how we can use comparison operators. Basically, we mainly use comparison operators inside conditionals, that is if, elif, else statements. Okay. So now we have logical operators. So inside logical operators, we have and, or, and not. Okay. So let's take 5 minutes break, then we will continue. Okay. In the meantime, you can visit the JNtech website for it. Okay, so here you can visit the JNtech website. So we will continue after 5 minutes. So now we can continue. Okay, so we were on logical operators. So in logical operators, we have AND or NOT. Okay, so we can use it. So AND means both conditions needs to be true. So here AND operator will check for the both conditions. So here both. So we have AND, we have OR, and we have NOT. So AND means both conditions needs to be true. For example, we have number one variable. In this we have 10 value. Number two, we have 5 value. Now here we're comparing the values. For example, print. Let's compare, for example, num1 is greater than num2. Okay. So we were checking for the conditions. Num1 is greater than num2. And we can put here operator num1. We can put num3 as well. Num3. We can put sin 9 here. Some even number. So num1, num2, num3. Num1 is 10, num2 is 5, num3 is 8. So you are comparing the values. Num1 is greater than num2. So which is true. Okay, now num1 is greater than num3 as well. So here which we are checking two conditions. First condition and second conditions. Now let's run this. Now what will be the answer here? So AND operator will check for both conditions. So in this condition and this condition, we both needs to be true. Then only we have answer true here. Okay. For example, num1, this condition is true. But this condition is also true because num1 is 10 and num3 is 8. And we are checking for the greater than it. So answer is 2 here. Because we are checking for two conditions. And in the AND operator, this condition and this condition both needs to be true. Now what if num3 is 80? So this condition is now true because num1 is 10 and num2 is 5, which is num1 is greater than num2. But num3 is 10 here, sorry, num1 is 10 and num3 is 80, which is this condition is false in that case. So we have answer false here. Okay, so we have answer false because here we are checking for both conditions. This one, uh, left side and right side, both conditions. If both conditions are true, then only we have to answer, otherwise we have false. Okay, so it is same like binaries. For example, we have 1. Okay, let's say 1 is true and 0 is false. Let's say. Okay, and if we have some operations like 1, 0, so answer is 0. Or if we have 1, 0, 1, so the answer is again 0. Or if we have 1 or 1, the answer is 1. Or if we have 0 and 0, we have answer 0. Okay, for example, 1 is true and 0 is false. So this condition is true, but this condition is false. So we have false answer. 0 and 1. So first condition is false, second condition is true, but still we have false answer. Now here both conditions are true, 1 and 1. Then only we have 1. And if both conditions are false, then we have false. Okay, this is how AND operator works. In OR operator, only one condition needs to be true. That is, now this condition is true, but this condition is false. But here we are like only checking for only one condition, or we'll check for only one condition. So your answer is true here, which is one condition is true. So we have two answers. Okay. So for example, in that case, in the OR operator, so here we can check. Or 1 is true and 0 is false. So first condition is true, second condition is false. 0 is false. So answer is true. Here answer is also true because here one condition is true here. Okay, and 1 1 is 1, which is true only, and 0 0. Now here both conditions are false. Then only we are false here. For example, here if we put 0, so num2 is 50 and num3 is 80. So here this condition is false and this condition is both are false. Then only we have answer false here. Okay, so or we check for only for one condition. If one condition is true, then only we have the true answer. Okay, so this is that and or operator. Okay, and same as we have not operator. So not operator is like opposite of opposite. Like if we have one, so we have answer zero. Or if we have zero, we have answer one. It is like reverse operator. Okay. So so these are all about operators. So we have comparison operators, we have logical operators, we have arithmetic, identity, and membership operators. Okay. Now we can move conditionals. Okay, so now we have conditionals. In this conditionals, we have if, else. Okay. So let's say we have a value num1 equal 10 and we have num2 equal 5. So we have two values here. Now, if we check for the condition where the num1 is bigger or 2 1 is like which one is lesser or greater. So here we can put if condition. If so, the syntax is like if your condition here, whichever you are checking, let's say num1 is lesser than num2, colon here and your condition. That is your set of statement. For example, we are printing print num1 is less than num2. Okay, so this is the condition. So if your if statement, your if keyword, your condition here, colon here, your indentation here, this is your indentation, this much, this is space is known as Python indentation. That is Python indentation. So basically, we don't have any that output because this condition is false. Because num1 is 10 and num2 is 5. Num1 is not less than num2. That is why this condition is false. And whenever the condition is false, this statement will not execute. Okay, so in that place, we can execute else condition. That is print now here we have the condition if and else. So if this condition is true, print this is statement. Or if this condition is false, so print this is statement. This is statement. Okay. So this is how if and else works. Okay, we have num1 variable, num2 variable. Here we are checking for the condition. If num1 is less than num2, okay, if this condition is true, then this will print. God, this will print. And if this condition is false, else will execute. Okay. So here we have a second answer that num2 is less than num1. And what if num2 is 50 and num1 is 10? So this condition is true now. If condition is true and we have the statement of if condition, that is num1 is less than num2, which is true. Okay. So now let's take a simple example here. We can check for the identity operator or for the membership operator. For example, we have a list of elements, list underscore 1. So here we are checking that we have list underscore one. So in this list we have various elements, like we have 1 to 10 elements. Okay, numbers, integer values. So here we are checking if 5 in list underscore one or not. If it is in list, so print this is statement. If it is not in list, so print this is statement. So here we are checking for only two conditions, that is yes or no. Right. Whether it is or it is not. That is yes or no. Right. That is it is or it is not. So whenever we are checking for only two conditions, we use if or else. Okay. So whenever we're checking for only two conditions, like yes or no, yes or like true or false, it is or it is not. So these are on that conditions. In that case, we use if else, only if or else. And whenever we are checking for more than two conditions, then we use if else. Okay, so here we can write whenever we are checking for more than two conditions, then in that case we use if else. Okay, so for the multiple conditions, we use if else, and for only two conditions, we use if or else. Okay, so here we are checking for only two conditions, yes or no, either yes or no, whether 5 in list, yes, or it is not in list, no. So we can use it. So answer is yes, 5 in list. Now here we can put 50 here. Now here we are checking for 50 is in list or not. No, 50 is not in list. So answer is no, 5 is 5 in, sorry, you have to put 50 here. It is 50 is not a list. Okay, that is not a list. So whenever we are checking for two conditions like yes, no, true, false, it is not, etc. So we use if else conditions. Okay. And whenever we are checking for multiple conditions, like when there's like more than two conditions, in that case we use if else. Okay, so let's take an example. So here we can check whether we will make a scenario here. It is whether a student is pass or fail. Okay, that is a scenario. So here we have only two conditions, pass or fail, yes or no. Okay, so in that case we use if or else. Okay, suppose we have a score of the student that is 50. Okay, and the scoring marks are that is 100 or 80. So we can put if scoring score is equal 100, 80, 100 then we can print pass. Else we can put, so here we are comparing the values. If the marks are equal to 80, so the student is pass, or if it is not, so the student is failure. So score is 50 here, so answer is fail. That is because score is 80, 50, or passing score is 80. Okay, so here we are checking whether a student is pass or fail. Only two conditions are there, yes or no, pass or fail, true or false. Now, let's take an example of if and if else. That is, we can take example like whether, let's say, assign a grade to the student on the basis of its score, of their score. Okay. Okay, so we will take a scenario here. We will assign a grade to the student on the basis of their score. Okay, like if the score is 90 plus, so answer is A, means the grade is A. Or if the score is between 70 to 90, so score is B. Sorry, the grade is B. Or if the score is in between 50 and 70, the score is grade is C and D and E like this. So here we will check for the score and then we will assign the conditions. Now here we can use the input function. Okay, so we can put here student underscore score equal, we can put int input because we are taking a numeric value. So enter your score. So here we are asking for the score from the user and the user is a student. Now here we can check for the conditions. We will create a condition. Now here we have more than one condition or we can say more than two conditions. Like here we have five conditions. So here we will use if, elif, else. So the syntax are like if, elif, else. So here we can put if or we can also put if, else. So elif is not necessary. If we have multiple conditions, we can also use if, else like nested if or we can use if, else. Okay. Or we can use if, elif, else, etc. So here we are checking first 90 plus. So the score, that is student score, is greater than 90. Then answer is we can put print. We can put the grade is A. Elif. Okay. Same as student score is that is in between 70 to 90. So here we can create a condition. So that is greater than 70 and less than equal to 90. Okay, so we have two conditions here and we will put AND operator here because we are checking for two conditions. So here we can put student score is greater than 70 and it is student score is less than equal to 90. Then we have print the grade is B, right? Now we can use as many if elif statement as we can. Okay, like it is often there's no limit of using elif statement or there's no limit of using if statement. Even we can use if elif else, etc. Or we can use if elif else, or we can only use if statement. So there's no limit of using these statements. Okay. Now student score. Now here we have a condition which is same as before, that is greater than 50 and less than or equal to 70. Right? So here we can put that is greater than 50 and student score so it's not even necessary to put else statement as well. Okay, so here we cannot put else. So else are like else is optional. Okay, so we can put elif or we can put elif. Okay, that is less than 30. So here we can put elif student score if score is less than 30. Then we can put print the grade is in. Okay, and rest we can put else. We can put Here we can put 100 as well. Okay, like 90 to 100. Just leave it. We can put here 90 to 100. Right. So here we can do. Now here we can put a statement if the user input, let's say 101. So this will print. Okay. So here we have to put the else statement here. So we can put um input score in range of 0 to 100. Right. Now we can run this. So a new terminal from here and we can run this. So clear the screen, move to desktop, clear the screen, name of your file data.py. Address code. So let's say 100. So your grade is A. Okay, we can check it again. Let's say score is 101. See, it put the score in range of 0 to 100. Okay. Now let's say we can put 50. So that is D. Because in 50 to 30 is D. Okay. And here we can put, let's say, 96. Answer is A. Or we can put 44. Answer is D. Like this. Okay. So this is how we can use if else statement. Okay. So here we can use only if statement, like if here, if it is not necessary to use if. Okay, so here we can even use if, and but we have to start the statement with the if only. We cannot start with elif or else. We have to start only with if elif else, or we can use if else. Okay, so it's your choice. Whatever you want to use, you can use. Okay, so this is all about your conditions. Now we have loops. So we have two types of loops in Python. We have for loop and we have while loop. Okay, so here we can put, let's say, for loop and while. So the syntax of for loop, loops are used for the iteration. Okay, for iterating or for printing something again and again. So here we can put range here. So here we will use range function. Okay, like if you print range of let's say 5. So this will run 0 to 5, like 0 and 5. And if you put range is like 0 and 5, so this will only print 0 and 5 only. Sorry, 0 and 6 only. So to print ranges like 1, 2, 3, 4, 5, 6, we use for loop. For example, let's say we have a for I in range 5. Print I. Run this. We have 1, 2, 3, 4, 0 to 5. 0 to 4. Because so the range start from 0 and it ends from 4. Because whenever you are putting 5 here, so it is like one step backward. Okay, one number backward. So here when you put 4, so we have 3 here, 0 to 3. When you put 6 here, we have 0 to 5. Okay, so this is how our range function works. So it is like in total, it is like 6 length. So like 0 to 1 to 5, 5 and 0, 6 length. Okay, but it starts from 0. Even we can start from 1 as well. So 1 to 6. So the answer is from 1 to 5. So the range is start from 1 and ends at 5. If you want to print number 10, like 1 to 10, so answer is 1 to 9. If you want to put 10 as well, so 1 to 11. So the range is from 1 to 10 here. Okay, now how this for loop works? Basically, for I in range, I is a variable here. Okay, you can name this variable as like anything. I is a variable in range. and range is a number. So here we have number like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like this. So this is like how a for loop works. Basically, first one will store in I and this will print I, and value of I is 1 here. Okay, same as 2. 2 will store in I and print I. So now value of I is, new value of I is 2. Same as 3 will store in I and this will print I here, which is value of I is now 3. So this is keep on iterating your value like this. Okay. For example, here we can take another example. Let's say we have a string name, called John. Okay, we have a string here. Now for I in new, print I. See, we will join like this. So basically, John is a string here, and it is like for I in name. Like here, we are iterating over this name John. So iterating over this name John. Okay. So J will store in I and this will print I. So that is J. Then O will store in I and this will print I. That is O. Okay, so this is keep on iterating or keep on saving in I and this will keep on printing I value. Okay, this is how a loop works. Until the condition is false or until the length of your string or of your list or whatever is completed. Okay, so we can take another example for let's say we have a list of list underscore one of some values. Like we have true value, we have false value, we have any number values, or we have some integers value, etc. Now we can look through this list. For example, for I in list underscore one colon print value of I. So here we are iterating over this list. So each and every element, that's true, false are elements. These will store inside I and print I. And this will keep on printing until your list is completed. For example, true. First true will iterate over I. Okay, so for loop will iterate over this list. So first element is true. So true will store inside I and print I. So value of I is true. Second false. False will store in I and print I. Now value of I is false. Same as 1.1 is stored in I and value of I is 1.1. So this is keep on iterating up to 4. Now last element 4. So 4 is stored in I and print I. So answer is 4. Now the for loop will check if there is any more elements. So this will, and if there is any no element, so this will execute or this will terminate the loop. Okay, so this is how your loop works. So we can iterate over any, like we can iterate over any file, we can iterate over any list, any type of data type, we can iterate over any range. Okay. So here we have a range function, that is, in this range we have few arguments. So first we have start argument, we have stop argument, and we have step argument. Okay, so start is like where your range will start from. Stop is like your stopping point, and that is step argument. Sorry. Okay. Start, stop, and step arguments. Step is like one step. This read statement will leave one step. Okay. So for example, we have this for loop for I in range. Okay. Now here let's put starting range. Let's say 1 is a starting range, end is 11. Okay, which will end at 10, and step is 1. Print I. So 1 means this will not leave any step. So it is like 1 is a starting point, 11 is ending. So if 11 is a stopping argument, so we have 10 is a value here. Okay, that is one step backward. Step is like whenever you are putting one step, so this will not leave any value. But when we are putting second value, 2. So this will leave one step. So the answer is now 1, 3, 5, 7, and 9, like this. So this will leave one step. Like we have 1. So this step argument leave one step, that is 2. And now we have 3. Leave 4, 5. Leave 6, 7, and leave 8, 9. So we have all odd numbers. Okay. And if we put 3 here, 3 means 2 step skip. So here you can see we have 1, 2, 3, skip 4. 4, 5, 6, skip 7. 7, 8, 8, 9, skip, we have 10. So here we can put, we have like, if we are putting one step, okay, as like we are putting 1 as a step argument, so no value will skip. Okay. So whenever we are putting 1 as a step argument, so this is like no value will skip. Okay, and whenever we are putting 2 as a argument, okay, 2 as a step argument, so one is when one value will skip, 3, 2 value will skip, and 4, 3 value will skip. So this is how this step argument works. Okay, now here we can put 4 value. So this means 3 value will skip. So that is 1. 3 values are 2, 3, 4, skip 5. 5, 6, 7, 8, skip, we have 9 here. Okay, 2, 10. So this is how the range function works. Okay. Now we have for loop. Now we have while loop. So let's take some few examples of for loop. Okay. So here we have a tuple underscore. So in this we have a tuple of let's say we have tuple like 1, 2, 3, 5. Sorry, it's a string. Tuple of numbers. We have some elements here. We have some strings here. Okay. Okay, so tuple, like we have these integers, we have strings, we have true and false Boolean values. So here we are iterating for I in tuple underscore 1. So whatever elements inside tuple will store inside I. So 1 will store inside I and print I. So now value of I is 1. Same as 2, 3, 4 like this. So this will return your tuple in this format. So this is keep on iterating your tuple until the last element. Okay. Same as we can like iterate over dictionaries, iterate over set and frozen set. Okay. Now we have a while loop. So for the while loop, so while loop works on the basis of conditions. That is, okay, let me show you first. So here we have a element I equal 1. Okay, so I is a variable here, 1 is an integer value. Okay, so this is an initialization value. That is your initial value. Okay, your starting point. Then we can put while I is less than or equal to 10. Print I. And this will keep on incrementing the I value. That's I plus equal 1. So this will print 1 to 10 values. Okay. Now let's understand this. We have a first we have to put I. We have to initialize a value. So we have to initialize while loop. So we have to put an initialization value that is 1. So you can put as like you can take any variable in here. 1 is a value here. Okay. Now this is a simple variable. Now here we are checking for the condition. If I, that is while I means values I is 1 is less than or equal to 10. Print I. If this condition is true, then print this statement. Okay, after this statement, we have answer is 1 because this condition is true. 1 is less than 10 and this will print I. That is 1. And here we are incrementing the value of I. We are updating the value of I here. Means we are updating y1. So previously now value of I is 1. Right, value of I is 1. Now here we are adding I value. Means here we are adding 1 value, which means we have I plus equal 1 means I equal I plus 1. Value of I is here we are updating. So you can write this or you can write this. Both are same. So value of I is 1. So I plus 1. That is I equal value of I is 1. 1 plus 1 2. That is 1 plus 1 2. Now the new value. Okay, so now the new value of I is 2. So now value of I is 2. So this will start from here 2. So now value of I is 2. So 2 is less than 10. Yes, and this condition is true. So now I will be printed. That is true. Now this will again increment value. Okay, so this will increment the value by 1. That is I equal. Now value of I is 1. Sorry, 2. So 2 plus 1, 3. Okay, now the new value of I is 3. So here we can put 3 here. Now here we are checking whether 3 is less than 10 or not. Yes, it is true. 3 is less than 10. So answer is 3 here. Print I. Now value of I is now 3. So this is keep on incrementing. Here now answer is I equal 3 plus 1, that is 4. So this is keep on checking 4, 5, 6, 7, 8, 9, 10. When here is 10, so this condition is true because we are checking for less than and equal to. Okay, so now this condition is true because a 10 and 10 are equal. So here we have a 10 answer. Print I, we have a 10 value. But here this will increment again. So here we have a value I equal values I is now 10. 10 plus 1, 11. Now here we have a value 11. Sorry, 11. Okay. Now this will check condition again whether 11 is less than or greater, sorry, equal to 10 or not. But 11 is greater than 10. So here we have answer. So this condition is now false and this will terminate your while loop. Okay, so this will stop executing the while loop. So we have answer is like from 1 to 10 values. At value number 11, this condition becomes false and this will stop the while loop. Okay, incrementing is very important. Otherwise, this will, if you are not incrementing the value, this will occur. So this will occur the infinite loop, which is like keep on executing. Okay, and this may be like crash your VS Code or this may be crash your system also. Okay, so incrementing is important. And why infinite loop? Because here we are, suppose we don't have this value. Okay, and while loop is like, it is like keep on executing until the condition is false. Okay, for example, this condition is true. So this is keep on executing until this condition is true. When this condition becomes false, the value will stop executing. Right. So here we have print I. Now here value of I is 1. So here we are checking for the first condition is 1 is less than 10 or not. So this condition is true. So print I. And this is keep on printing the like one value because now here we are not incrementing any value. The value of I always remains 1. So this condition is always right true. So this is keep on executing for forever. That is known as infinite loop. Okay, so we have to stop this infinite loop. So we have to increment the value by 1. Okay, so we can keep on incrementing value 5, that is 1. Okay, So we can run this and we have a value. If you remove this, let me show you this infinite loop. So you can see we have 1 1 1 1, and this is like if we're executing, so it is stop this from here. Okay, so don't forget to put this incrementing value. Okay, otherwise this will crash your system, or this will like crash your VS Code as well. Okay, so this is how in while loop works. So we have to initialize the value. We have to put while. The while is a keyword, and here we have to put condition here. If the condition is true, this will execute. If condition is false, this will terminate. Okay, print type whatever you want to print inside while loop, and or whatever you want to iterate inside while loop. And we have a incrementing value, that is I plus equal 1. Sorry, I. Okay. Now we will take some examples. Okay. For example, suppose let's say there's a while loop, okay, or there's a for loop. So and we as a developers asking users to input the starting argument, the stop argument from the user. So what we can do, so we can put here uh, ask asking for the, or we just put take input from the user for the starting and stopping, or and stopping range in for, or we can put in for and while loop. So the syntax is for I in range. Okay, we have to put start and stop argument. So let's say 1 or 10. 11. Print. Okay, so this is a basic syntax. Now we want the user to input start and stop argument. So here we can put a equal int integer input. Enter the starting argument, starting point for starting point. Just put this. Okay. Same as b equal int input. Enter ending. Okay. So here we can put a value of a and b, a comma b. So whatever the user will input, this will store inside a and b, and we are using those value here. Okay, like a and b here, and we can printing values I. Okay, so we can run this. So here run fine. So starting point, let's say 50. 50 is my starting point. Ending point, let's say 101. That is 100. So 50 to 100. So you can check it out. We have answer. So starting from 50 and ending at 100. Okay. Now, same as we can do with the help of while loop. So here we can put I equal int input, the input starting position, that is enter the starting point. Okay, here we can do this. Second, we can put, let's say ing int input. Here we can put enter. So now we can start. We have I and we have j. So we can put y. I is less than or equal to j. That is our ending point, and we can print the value of I here. And we can increment. So incrementing the value is important. Equal plus equal 1. Okay, now here we can run this using terminal. Okay, so clear the screen. Starting point, let's say we can put this in, let's start from 5. Okay, ending point, let's start and 10. So that is 5 to 10. Sorry, 5 to 8. That is because of this equals. Okay, so starting point of my while loop is 5, 6, 7, 8, 9, and 10, and 11. Okay, and we can, if you are removing this equal sign, now we have, let's clear the screen first. Starting point, let's say 5, ending point 11. So that is 10 because we are checking for the condition if I is less than 10 or not. I value is 5 and we're checking for less than values j. J is your stopping value and value of j is 11. That is this one. Okay, now here, so answer is like 5, 6, 7, 8, 9, and 10. Okay, so this is how we can use value. Okay. So now here we can ask for the user to enter a list for you. So here we can ask for the user to enter the list. So list underscore 1 equal, or we can just take a string underscore. So input, let's say enter any statement. And we can put here read, we can put for I in string str underscore 1 for I in, and we can print value of I. Okay, we can run this. So Python interpreter will ask for the string, that is we can run this. Enter your string, that is, let's say, or any statement, let's say Python is a powerful language. So this will iterate over this statement. It is first Python is space a space and powerful space language. So this is how a for loop works, and this is how you can take input using for loop or while loop. Okay, so I hope this much is clear. So now rest we will continue in the next weekend. So if you want to check out the previous video in session number 1, so you can visit the YouTube channel. So here you can search for the channel name, that is GPGS1. So from where you can watch the previous session number 1. Okay, and if you want to check out the post content of Python, so you can visit the JNtech Networks website, that is jntechnetworks.com, and here you can check it out the very post content from here. Here you can check the models. Here you can check the fee structure, the course duration of core and advanced, as well as if you have any inquiry. So you can call this number, or you can mail, or you can WhatsApp. So feel free to ask. Okay. So rest we will continue in the upcoming weekend. Thank you.